Marc's here to deliver the keynote, Immersive Architectural Legacies. So thank you very much for joining us today, and I'm just going to hand it straight over to you.
Yeah, wonderful. Okay, great. Yes, I try to talk a little bit about different VR approach, different thinking in design, and sort of stimulate you in different directions, not necessarily give you now one project and one research, but just explore different things. And I want to start it off with the movie Shift, and I jump it a bit because otherwise we just watch a very interesting movie. So there is this guy sitting in his living room and doing very interesting exercise. But what he's actually doing, he is playing a video game, so he's flying through, and so he is fully engaged in VR. It just looks different from the outside, right? So anyway, so he goes then on, and now he's a bit hungry, so he want to eat something, and he has no idea how to chop an onion or a carrot, and the AI helps him to chop it, and he gets a score that he can chop that very nicely. Kind of funny that, you know, and you can't really chop your own thing. But anyway, so he goes on, and he eats then something, and then later on, he goes on a date, and that's obviously also online, all organized, and he sits now with a girl, and is very happy to meet her, and tries to now start a conversation, and go a bit forward, so he doesn't really know what to say, and so he has all his apps to say, oh, go, what kind of smooth talking can I bring now? So he has his wingman to help him to what to do and to score. On the other hand, you know, the girl has the same thing and can also find all the background data about him and says, okay, that is not really going good, you know, it's scoring directly, another bad day, it doesn't work, and so on, right? So then anyway, the wingman helps him to, you know, order the right bottle of wine, and suddenly things change around and things go a bit more interesting in the develop, and gives him all the time tips what to do and what not to do. And so this conversation obviously goes on and seems to be a little bit better, and then they end up in their apartment back there, and I'm not telling you the end of this. But it is actually quite interesting if you see that as a vision of how VR, AR, sort of in the future, how we work, how we live, how we use all these assistants around us and not be able to make our own decisions, or how our own decisions sit in conflict in our own being with what the optimized environment gives us and says, look, you have to do really this one, this is the best, but we want to act differently. So this is a fairly old slide now, but this was in Binhai in China, where they said, okay, we need a bit more buildings and we need more, we need to build more. And you see here, they were the projection in 20 years, they needed 45 million homes to be constructed. That's quite something. And if you look at how, in terms of how you can actually do that, I'm not saying the sustainability around it, but how can you manage to build and build the right thing, which is then actually usable for a long time, and which generates certain cities and certain city profiles. And we see here some mega cities and the population, the density. And I don't have an image of Sydney, unfortunately, but you can probably imagine it becomes very flat in terms of its population density. So this is sort of different built environments where we have on the left side kind of that dream. Everybody has their own acre and their house, and which is very typical to Australia and New Zealand. But you have then other cities like Hong Kong in the middle, and on the side where it's a very high density and living, and your environment means something very different. And what you are, what you do, and that is defined very differently. Now, as architect and designers, and also what you do, is you use now digital media and technology to as a tool to operate and to engage with your environment. But I think that it becomes very crucial that we see the digital technologies not only as a tool to operate, and we operate and we're the master, but much more as a way of how we think about design, how we think about the environment. So that becomes actually a shift that it's about the thinking of how we use certain things rather than just having that as an operation tool. And Autodesk has that slogan a couple of years ago, change is anywhere, change is everywhere, and saying, you know, now we have the different tools and we can all the time change and adapt things. Yes, but this is actually definitely not what we want. We don't want to change all the time. You know, if you do your assignment and your tutor says, well, that's very good, but do more, do this differently, you're constantly changing and you never finish. And you only finish when the deadline is, and that is a very daunting thing comes on top of it. So how can we actually do something where we don't need to change, but we do the right thing from the beginning? Another quote, I bring you a little bit quotes, it will ease with the quote later on. Descartes was a French philosopher, and he developed the idea of the dualism of the mind and the body. So for example, if you want to go on a diet, that is a decision in your mind, you want to reduce weight, so you don't eat. And then in the evening, you feel just really, really hungry. And in your mind said, no, I'm a diet, I'm not eating. And then maybe the next day or in the middle of the night, you run to the fridge, open, and you eat because your body tells you, I'm hungry and you have to eat. So there is this play between what your body needs and what your mind can do, and you can sort of have that interplay with each other. And I would translate that in our working environment where we have the digital tools and the digital media which can do certain things and we can do certain things, and how can we have an interplay between these two to actually come to an intelligent solution in that environment. Now, this is an image which you may have seen already, the realm in which we sort of interact. On the one side is the reality. This is we being here. On the other side of the spectrum is the pure virtuality, so which is not real. And I would actually question the term of virtual reality not being quite right, because it means that is a copy of reality. It's a virtual copy of reality, and it's not its own, so I would call it much more the virtuality. And you have the different media and stages in between. And we're acting in this realm all the time, using the different computation and gadgets we have. So we're dealing always between a real and a virtual environment. It's nothing new, the idea of virtual and to having an idea and see of how you get there. So this is a drawing from Peter Bruegel, the Tower of Babel. And so there's a story from the Bible where the people wanted to build a tower as tall to reach heaven to see, to meet God, basically. And at that time, well, they had no idea to build such a tall tower, and you can see that they started building this tower, and then they realized, structurally we have to put another ring in there, so we have to make it bigger, and then we can go higher. And so there was a lot of adaptation, and there was actually making the changing while you do it. So they had actually an idea, we want to do a tower to reach heaven. We have no idea how you get there, but we do it while we do it, we observe, we frame the problem, we move and reflect, and we move on, and we get somewhere. Well, they didn't get quite up there, but that was the idea of it. Now, this is a little bit what I show in relationship to, for example, where we typically work, and it would be nice if we have the other side. So, for example, if you do your assignment, you start at the beginning of the term, and you said, there's plenty of time, and you do your thing, and you do a little bit more, and then you come close to the deadline, and suddenly you have to work really, really hard, you do overnighters, and then somehow, bang, you're there. But your design development is at the beginning very slow, just a little bit, and then a little bit more, and then you do everything at the end. Now, ideal ways would it be if it's the other way around, if you could set up everything at the beginning, and all your design is done, and it doesn't really matter when the deadline is, because the curve is so flat, and this is just really fine-tuning little thing, and that's not the point anymore. And this is actually very interesting. Can we now use our digital environment to help us to move from the left side more to the right side, so that we actually don't have to spend overnight there? Sure, we are in Sydney Opera House, but it's an interesting idea of when the idea was there and how this was then conceived. It is not a building which you would imagine or what you would describe in a planned section elevation. It is a building which is three-dimensional, and you would describe it much more three-dimensional, and to develop plans and to describe of how you build it in a construction process, you would not use conventional method plan section elevation, because it just would not reflect what the building is. So you need different means to convey this idea, and there we think much more of it three-dimensionality. While here the blur building is also a very interesting building, because to describe that building, you just say basically it's a cloud. Now, a cloud is not a defined, clear form where you can say it looks exactly like this. Basically what it is a platform, and there's this nozzles, there's sprue water, which then become the cloud. That is all what you need to describe the building, no planned section elevation, and you suddenly you achieved something which was a very abstract term, but using and describing something from a different way, not from a clear descriptive way, what a computer would need, but much more from an imaginary way, where you say, okay, cloud, I know what a cloud is, and it is something which changes, and we can very clearly then define something. This is where we engage a little bit in our environment here, sort of in an academic environment, but also in a professional environment. So how we not only design where we just think, oh, let's do that because I wake up in the morning and I feel like this, but more like, oh, we want to use the design and what we do there and research around that and be actually more accountable of what the design is, and be then able to make the right or the wrong decision, or make a decision where we know it goes in the right way and we know that the other one is the wrong way. So it shifts a little bit the idea of the star designer or the designer in the center of the design towards an idea where where designer surrounds themselves with different media and different technology, where the design sits in the middle, and we tackle that design with different media, with different ways, different representation, different ways of how we communicate physically, virtual, in a combined way, until we are satisfied with the result. And we have different aids and supporting mechanism in this context, which help us to make the decision when a result is right and when we want to have this design. So it's not necessarily a time-based decision, but it's a decision of where we come with an idea, using different tools, using different translation of the same thing until the design comes out. Now, we talked also in the podium discussion earlier about ideas which were developed long time ago. And on the left side, you see an image which was in the Fortune magazine in '55 of what an architect is in the future, how he works with a computer. And it's exactly, basically, how we still work. So you have 3-screen, plan, section elevation, or isometric. You have a keyboard, fairly big. You have something like a mouse. He's holding some control thing. This is a mouse. He's connected to the internet via the telephone, and he has the cloud and the hard disk here in the background. So it's a fairly big hard disk. Things now become a bit smaller, but basically the environment in which the typical architectural practice happens is still very much the same. If you use here, for example, any software where we have the plan, section, elevation, we have different things. We use with keyboard and mouse and so on. Now we in recent years, we have now more VR and AR, and that is maybe the first time where we shift a little bit of what working means, how we design, because within a VR environment where you don't have the same access to you have to think differently of how you manipulate and how you design something, because you don't use a keyboard, you don't use a mouse, so you have to think very differently what are actually the operation and what are the metaphors that you can operate in this environment. It's just very interesting when you see any picture of somebody using VR that the mouth is open. There must be something on that one, I haven't figured that out. Anyway, so looking at how we use certain tools in a way where they originally were not intended, but allow us to think very differently and produce something very differently. So we see, for example, on the left side, photos from Man Ray. Man Ray was an artist in the 30s of last century, and he used photography, keeping the shutter open very long time, to generate these kind of images. So the camera was not developed for the idea to do this kind of images, but he understood what the technology is, and by that, you could say in a certain way, misusing, because it was not intended for that, to generate something very different, in this kind of context, a very artistic way, and was then come out with this. The next image is Jörn Utzon, who designed the Opera House, using a torch and camera to sketch something. Now, this is also nothing very new for you, but this is very interesting. While he did the sketch and while he moved through space, there was no sketch. There's nothing that you can see what he did. But using the photography and the opening time of the shutter, that allows you now to understand what the sketch is. So he used a medium where you can't see it, so he sketches virtually, and then you see it in the photography, the outcome, the impact of what the design was. The same thing is then on the right side, where you have a mobile with 2D shapes on wires, and they move in space. And that's also interesting of how 2D shapes are translating themselves into 3D through the movement, and then using, again, photography to make a very different expression of the same thing. If we look at the images on the right side, since we are all trained to think three-dimensional, and I told you it's a mobile, you don't just see white lines and dots on a black background, but you see actually spatially. You interpret the same image spatially without that there is actually space there. And that's interesting. So you see something which is not there, and it becomes, by the interaction with the medium and the technology used, that you then can read something and discover something which is originally not there, and you see that spatially. Quickly want to show of what Mari Capo was stating in his book, and he was talking about the digital production and media, how that actually has an influence, but he talks also about participation. And I think that is a very interesting topic of how participation, not from us as designer with digital media happens, but of certainly of how all stakeholders can participate in the design process and in the outcome of our design. And that is actually the very interesting tool that we now allow the medium, and the medium allows people to engage and communicate with architects, with designers in a way that they are really can make an influence on what it is, so that it removes basically the authority from the architect and the designer to people, and there becomes a very different engagement. And it's only possible because we have a medium which can interact and can translate the ideas and the language to different people. He also says that we as designers need to engage in the production of the tools, so we not only making the tool. The tool becomes actually the code. We have to write what the computer does, so we're not just using the computer, but we actually have to engage in the production of it. Now, imagine you walk along on the street, and somebody else walks on the street here in that on the alley, for example. You all have your own experience while you walk in there, and you see different things, and you walk a bit more on the right, on the left side. But this collection of all these experiences walking down the street defines what the street is. Similar, you sit here in the auditorium, and you all sit on a different angle, and you see now the presentation from a slightly different angle, but altogether you see the same thing, and you have sort of a collective experience of that presentation now. Now, if we can sort of capture these different experiences and lay them over, on top of each other, we can actually think about what is the experience in a street, or is a street the leftover of the buildings, or can we do the other way around, can say the buildings become the leftover of the street experience. And that is again a very different thinking and shift of what design means, that we not design the object, we design the void, which then defines what the object is. So for example, the market here in Hong Kong, they all have the same footprint. They pay the same rent to the council, but how they organize now the market stalls, what they sell, some have a larger roof, a smaller roof, some have no roof, some have certain objects, different things what they sell. That makes the market so interesting. That's why we go there and why we experience it. So it is not the unify idea, but it is the flexibility which the system allows. Everybody has the same footprint, but it allows for this variety. And it goes even further in how the building in the street is designed. So there's different street signs, how they go into the street, and how they layer in different heights and different colors and so on. So giving a certain rhythm to the street, and further on of how the balconies and how a certain adaptation to the normal building was undertaken to allow a personalization of your space, but at the same time to give a certain character of what the street is and how that is done. All right. That goes back to what we said actually a couple of times now in the podium discussion. What is the problem and how can we frame that? And I would actually say we don't have a problem. We make the problem. If you go and open the screen, it's white screen, there's nothing on there, or in the conventional way, there's a paper, there's a white paper, there is no problem. It's everything there. But the moment you draw a line, you define what the problem is. It's either on that side or on that side, or the space is divided in this proportion and that proportion. And by then, this way, we frame the problem, and by that we move on and we think about it and say, okay, what is the second line? What is the second thing, depending on what the first one was? So we maybe make a decision, we get rid of the first line, or we add something else to it. So we actually constantly framing the problem, making a problem, look at it, and then evaluate that and move on in this way. So the interaction between the human and the tool, and that what we do, this is a very interesting interaction which all works together. So the way of what we think, what we maybe, how we get inspired, as well as how it's then translated and how it's then generated. Now, this building you all have seen in publications. You could say it's fairly complicated, fairly complex, and I don't want to talk about design, but more about how you now can produce something and how can you now frame a problem and use the tools which you can do that. Obviously, you will use a Grasshopper script, and we saw today a lot of Grasshopper script, and I would actually say we are in the time where Grasshopper rules the world. What would we do without it? But it's interesting of how we use suddenly a coding system to design and make the design and influence design and work actually with Grasshopper as a partner and with Grasshopper as we expect that the software does certain things for us because we are not able to do them in the same way or they would take too long time. So we use for a certain automation process, that's the same building, the same script for that building, of how to generate the connection points that they, how they would look like. And then even more, we use then AI to write a software which writes the software to generate the outcome which we see, and this is all the more details of the same knot which you saw earlier. So it is a fully automated system which now generates all the connection points and everything which is in there, and it's a software which was written by a software. So we are actually not in control anymore what the software does. We just say, generate something that I can come out to this outcome, and then the software does it, and then we look at it and said, yep, that is exactly what I wanted to have. And it looks then like this. And then you can, from that, you have to fabricate that, and you press a button, and it can generate you, a million drawings, typical shop drawings, which you in other ways would not be able to produce, because to produce a million drawing by hand or in a conventional way using, for example, AutoCAD or tools like that, you would not be able to produce it in a meaningful time. And if you have any changes, it would update them automatically. Now these plans, this data, as accurate as it is sent then to fabrication machines, which then produce them and cut them out, and then you label them accordingly, bring them to the site, and it's a big puzzle to put them together. But what I thought is interesting in this, so the workflow to come to this point is highly automated, it's highly computation, it's a very intelligent process. It goes to the machine, which actually cuts it out for you, so you don't have to do something. But to operate the machine, it's very analog. There's this guy, he has to press the button, he has to fine-tune the little thing. So he has to understand of how the machine operates to generate the precision which the whole computational workflow earlier did in the first place. And it looks like this, has a spreadsheet and has to punch in the numbers into the machine that it comes out. So there is a break in the whole automation process in the moment when it comes to the fabrication. Now this is machines which fabricate, but if you think most buildings are assembled by hand, by labor, and they may be aided with certain machines, but there is still the hand process. And that's a very interesting moment when you have the whole production of the building all computational aided and or generated, and you come to the moment where it's produced then and put together, not automatic, and but by human beings. And it can generate such a design, very nice, right? And you have then panels which have double curvature and different holes, and then you have to think about, okay, you have 1 million of panels, all double curvature, how can we actually produce them in a meaningful way? And that is again where I said the architect has to develop the tool. So the architect thought, okay, I want these panels, I cannot produce them any cost effective and they're double curvature, so I have to produce now a machine which can bend them for me, and for every little different panel it can adjust itself without that I have off-cut and so on. So basically the architect then developed this machine which has different bolts, and they can go up and down, and they were basically all adjusted, and well, the person has to put in the piece of metal, and it's then bended accordingly. Coming back to the virtual context. So we have the virtual building, and we're talking now about the digital twin, which is, you could say, per se not a very new concept, but it is about how we can actually produce something in a virtual context before it's built and to see whether it works and it's tested. So this is the Island 1 building in Hong Kong where I was partly involved in, and it produced conventional this kind of drawings. And as you can see that in that way that nobody can actually read them because you can't understand anymore. And if you want to detect a clash, that's just impossible. So that's why you go to three-dimensional information and see that all three-dimensionally, because that is the way of how you can understand the data and you can build with it. Now, the computer is good in detecting clashes, but they are not good in solving the clashes. So you go there and there is no automatic clash solver. There's an automatic clash detector, but not a solver. And that becomes an interesting part, that we as human, the machine is able to detect the problem, but is not able to solve the problem yet. And so it becomes very, very interesting of how different clashes, some clashes are so simple they can be automated solved, but it becomes then where we come in, understanding it three-dimensionally, understanding the hierarchy, understanding the process of how things are put together, that we then can solve the different problems. And here we can solve problems, right? So on the plans, it's like the pipe goes down, goes in there. Oh, there's a window. What do we do, right? So this is how we solve problems, and it's actually quite interesting, right? So we have that amazing BIM model, and we have that all computational done, but then it comes to moments, and this is how we then can solve things, and it's quite elegant. Or here, the airport in Hong Kong, a lot of money went in there. Foster built that, all virtually designed beforehand, and they forgot the holes in the last beam. So the whole idea that the pipe is nicely goes through there, and everything put there is just, goes down the drain. So clash detection, it was detected, everything, but it was then, by the end of the day, not solved. Now these beams, you could say it is maybe the labor here forgot to put that into the formwork. Yes, because we're human. We do things, and we do things wrong. And then we're able to fix our problems in that way. And it's the most, it's a very flagship airport. And you walk by and you probably won't realize, because that's normal. We are normal to use to errors, and we actually can enjoy them. Same time, this is also how we build, right? This is a tolerancy from 12 centimeters. This is sort of supposed to be a flat surface, supposed to be, right? So now you have your BIM model. Absolutely pristine, straight line, one part sits top on the other, you go on the construction site. How you deal with that? You cannot go back and say, well, in the BIM model it tells me it's straight and it has to fix. So you have to think about how you now be able to use certain tolerances, or even if you have no tolerance, how do you now proceed in this one, and how you now change your system, which you have there, that it can react to this to reality. Now, I don't want to make any comments about software, but I was involved in developing the software using a game engine to simulate the environment which we have. And that is actually also quite interesting now, that we use now a more gamified environment to explore what the virtual model was. So I showed you earlier in the Island 1 building the virtual modeling of the MEP, but it's very dry, and you don't really go through. And now the whole idea of using Unity, and we saw a couple of projects of you who use Unity, and another sort of gamification environment suddenly allows you to put in different software in a game environment, and then to modify things and do it on the fly in real time, because you can relate to it in terms of scale, in terms of going through, and it is in a certain way also entertaining, so that is a gamification aspect, that you actually enjoy doing this, and suddenly the whole collaboration of working becomes something different, because the whole heavy lifting in terms of the computation power is done in the background, and you do the fun part to explore what the environment can do. All right, let's go next slide if I get there. Okay, this is a similar thing. So you can now use the environment to also schedule and have the sort of how things are built, and that is also not nothing new. But the idea is that you be in a very gamified environment, and you can test how you can go through. Do actually your things fit into the construction site? Can you deliver them? Can you bring them up there and address the whole schedule of the building, and actually see on the building when you have clashes how you could solve them virtually, because you play them through, and by that you have a very different way of how you communicate the building. And now if you have that game environment, you can communicate it also to the people who put the building together, because they suddenly have a full understanding of what the building is, rather than they just be on that part and who cares what else, and I just do that and I go. They understand that they actually contribute to something, and suddenly it becomes a very different engagement for them too. Let's go a little bit more to the heritage context. There is in London the Hampton Court and Palace, and it has a room. It's called the Chocolate Room, and this is the way of how before they renovated, how they found the room. Right? So it looks like this, and then they said, okay, we do a museum, do the renovated, and now it looks like this. So which one is the real one? Which one is authentic? The way of how it's found, somebody put the bottle there and the dirt is there, or now putting very clean, put lots of nice things in there, which never have been in the room, which never have been used by the person who lived there, and generate now an environment which is sort of the virtual idea of what the palace was, 100 years ago, and suggest a certain authenticity, which is actually not the real one. On the other hand, the left side is also not the real one, because it is just sort of a leftover, and it is not really of how the person lived. So how do we deal with sort of authenticity in that context of heritage, of physical heritage? How do we deal then with a digital heritage? And by digital heritage, I not mean only now a copy of the reality, and that is then in VR, but how do we deal with items which are only exist digitally? So if we have, for example, our BIM model, which we built in the first place, or if we have a certain computer file, or if we have a computer game, so there is no physical representation, how can we deal with that in terms of heritage and make that accessible and have a value to it and have that as authentic? In Wellington is a modernist building which is called the Gordon Wilson Flat, and they're empty because they're earthquake prone, so since 15 years it's empty. And the university it belongs now to the university, would like to knock it down and expand the campus. However, it's heritage listed, and heritage would like to keep the building. So we have now a real building which cannot be used because it's earthquake prone, and it falls slowly apart, and one side we want to keep it, the other side we don't want to keep it, and nobody can access the building and understand what the building is. So what we did is we built a virtual model, and we put it into sort of the context of how it was built, and we can do certain things with the model, and we can pull out different apartments and allow people to go through and experience the building, and by that not only see the building as, oh, there is a building which falls down and we want to take it away, but actually to understand what the building is and allow to form their own context of what that heritage means for them. So we did 3D scans and photogrammetry of the buildings, put them together. We did the laser scan and put all this information together and collected oral history of people who lived there in that time to tell a story, to build a virtual experience where you now can blend over the pristine CAD file, the digital model, with the photogrammetry, which shows the real the situation, how it's now. And you can go through in VR, or you can have a projection screen, and by that you can now access and you can make your own context to what is actually heritage for that building and what does it mean for you. And so we, developed obviously more that we saw that part already, see whether we see other things. So this is the inside the model, and we put some furniture in so that people just have an idea of what the scale is. And you see how it swaps between it. You can control that swapping as it's just in the movie a bit faster. What is the real situation? What is the pristine version of it? And by that you understand what the space is. You can go in there, which you otherwise cannot go, and you see the view out of the building. So it's suddenly you can own the building by yourself, and you can own the apartment and have by that not a digital twin, but you have a possibility to now decide, is that heritage? Is that a building which we should keep for the city, or should we take it down and do a search for other possibilities in this context? Let's go next slide. So we made an exhibition in Wellington, and we called it the Immersive Legacies, where we have obviously panels with different pictures. We built a physical model using laser cutter and 3D printing, so using sort of digital technology to generate the model. Put this together. We have a very big screen where you can go in with 360 movies and experience it, and we have obviously the VR experience, which you saw partly in the movie. Some more of that holographic model, and which looks something like this. So where you can explore the building, and we pure in terms of its form and how it's put together, not in terms of its materiality, but to understand the proportion and how the spaces are defined. And it goes then on to where you have only the 3D scan to see of how the building is in terms of its in a current status. And this is just a quick run through the whole space of the exhibition which we had. It's in the Wellington Museum, and it was very interesting because the building is very highly discussed, and it became a political issue whether it should be taken down or not. But it was suddenly the first time where people could actually access the building and had a better understanding, and it now sparked a very interesting discussion around which now is much more an informed discussion rather than just something which you have experienced from the far distance. Okay, so that's the model. People go around. And we showed the tools and the technology of how you actually produce the things, so to allow other people also to produce something like this, because we don't use any high-end equipment, but it's really very basic material and equipment, so that people can actually do the same thing in their context. And then again, people obviously using the thing full of fun. So what we are interested in is also the idea of a social VR. So social VR meaning that you're not in your headset alone, but that you actually share the environment in which you are, and that is that space which we have, where you can, without any gadgets, can interact with the virtual environment. So you have the screen, and you stand in there, and you can discuss things, and you can navigate through the space using a smartphone, and it tracks the smartphone and the movement of your smartphone to help you to navigate or to interact with the space. So you don't need any other element than your smartphone, and you can start sketching and interact with the space, as well as talk to each other. Now, we used that in a project using Kashgar, which is the most western city in China, and that is the original city. It's a very old, ancient Arabic city. It's on the Silk Road, and China decided to develop the city and the environment for people living there, basically by knocking all the old town down, just keeping a little bit left over, and so that is a photo of the environment, and you see how the pressure of the environment is. Some part is already knocked down. You see the other parts of it. So we went in there and took with drones and pictures and used photogrammetry to capture the city and the parts which were still left. And this is how now China basically captured the environment. What you see there is not old, it's rebuilt, looks like old, plus some neon lights. I don't know why they are there, but and make this whole city now payable. So you have to pay to go in there to see a fake old city. And that is very interesting, because before you had a very nice city. Right? You had, when I go back to that slide, you had an environment that is all there, and people lived there, and it's authentic. That is what it is, and you didn't have to pay for it. And people were quite, I would say, quite happy living there. They maybe had not the same facilities as what you have in a modern apartment, but so you change the environment. You take away. You use the bricks which are there and reuse them to build something new, old, new. You charge, and now you have the real experience. It's kind of interesting, right? So what we did is, we took all the images, the photogrammetry, put them together, and now allowed with sketching and allowed with people to work on the city and to expand that and to develop the city in that virtual environment. So having now a heritage basically in a virtual environment. And the same as you can take bricks and build something new, and it was always a tradition. Somebody needed a bigger house. They just built another room on the side. So you can now go through the space and you can capture textures, basically bricks, take them, collect them, and then apply them on areas which are not built, or you can modify the cities in the way of how you want that. And that is exactly the spirit of how Kashgar was built in the first place, that it was a growing organism, how the people who inhabit it modified the city. And so this is some screenshots, and now this is an environment, just a movie where you see a little bit how it looks like. We put extra the atmospheric event, sort of similar what you have now here a little bit with the environment. Kashgar is next to the desert, so you have often desert storms, and it comes in and then the light changes. So this is a drone flight capturing the environment. And so then that is obviously then translated using software into the mesh with the textures, which we then can put into a game environment. And you see that the scan has lots of empty spots and errors, but we use that as a way that you now allow to modify the city and to develop the city and add your textures which you want there. And you can use it with headset or without headset, so you can use it in that way. So the idea is that you be actually very low tech and without gadgets, and you can interact with the environment. Okay. Opportunities. The glitch, I think that is a very interesting thing, which we haven't really talked about it. We all opened up an image on our computer and it's just not there, it's just fuzzy. Or we open up an animation and we don't see anything, it's just pixels. And that's very interesting because the data is there. It's the clean data on the hard disk. The machine, the computer works, but something doesn't work in terms of the synchronizing the data and the reading, and we get this glitch. And that is something which is, you could say, very human. We can relate to an error. I showed you earlier the pipe which didn't go through the hole. Now, how can we use this glitch actually to in our design and using this occurrence of the glitch? And there are some samples of how glitch is built, but we are not interested in just building the glitch, but we're interested in using, for example, this picture which is on the left side, which we opened later, looks like that, on the right side, glitched. How can we now use that as a starting point for an interpretation which is contemporary and which is architectural? So we are not interested in a forensic going back to capture the original picture, which we did so that we had the picture, but we were interested in using this information now to interpret it contemporary, to read this glitch and see what that means architecturally. So we can now use, again, Grasshopper, different script, to interpret the different colors and the different sizes of it to develop an environment like this. And then we can apply colors and textures to it, and suddenly it becomes something like this, very in the more abstract context. Or we can make that as a movie, and it's very interesting of how that movie is now a glitch in the glitch, because the objects, the cubes and so on, they sit in the same coordinate. So now the computer does not know what to render, the green or the yellow, because they sit in exactly the same coordinates, and it sort of flips back and forth to show, this one is now wins, while the other one wins. And that is an interesting thing, that you use the glitch in the glitch, basically, or you play with the computer to see how they react actually to a data which you generated, not with the idea that you generate a glitch, but to actually basically play what the computer can do. You applied, different materials, and you can apply sort of more architectural materials of glass and steel and concrete, and you get this kind of outcome. And now, again, as architects, we are able to read that very nicely three-dimensional, and it has no scale, so we can sort of make interpretation of what that means depending on the scale which we put in there, but we can also just see it as an interesting image. But now, what you see there is the same data from the girl standing in the kitchen in front of the fridge. It is just a different way, using different tools for a different interpretation of the same thing, of the same data. So it is not about whether the data is right or not. It's about how we use the tool or different tools on the same data. So you can have the tool which shows you a photo, and you can have a tool which shows you now an architectural interpretation of the same thing. Yes, so I'm kind of winding up now. We haven't really talked about Internet of Spaces, Internet of Things. One presentation today I heard was a little bit about it. We talked a lot about certain gadgets and certain applications and apps, what can do certain things. That's all good. But what I'm actually more interested in is how these different gadgets, the different elements, the different sensors define the space. So I would more call it the Internet of Spaces rather than Internet of Things, because then we think about spaces that think about that we interact in spaces. That's where we are. That's where we sort of work as an architect. And it comes back to the street, which I showed you. Is the street the leftover of the buildings, Or do we design a street and the buildings become left over? The same thing is the space and the Internet of Things, is that generates a leftover space, or is a space there where we interact and the different gadgets help us in this context. So an ancient drawing from China, very interesting, it's very dense, there's a lot of street life, it's about the space how people interact. What you see is not so much how people, what they do in the building, but you see what the people do outside in front of the buildings. So it's about the spaces. It's also of how the space is portrayed here in this terms of a parallel projection. But I think it's a very interesting way of storytelling. Other way of how we deal with space and the internet. So, for example, there was 12 years ago, the biggest land party. So these people, over 15,000 people, all together work, play in the same environment at the same time, in the same location. They could have done it elsewhere, but they come to the same place because that is, again, the experience they have together, and then they go from that physical environment to a virtual environment to interact in that environment. Very interesting experience. However, that's mostly our experience. And there's something wrong. So how can we move that reality, to make it actually, it's not about a game, but to make it what the game offers us, really the excitement and the interesting part, and how can we now use computational media to make our life interesting, rather than that we become the leftover and it becomes the worst game ever. So that's a typical architectural studio. Probably a bit different here, I don't know, but that's a studio in Hong Kong where I was earlier. So you see somewhere a student, but it's mountains of stuff and so on, and it works in this environment. And it's very creative, it's very good, but it's not quite, we're not quite there yet. Now, this is an architectural office in Hong Kong. This is horrible, There is a person, you hardly see him, there's another one there, mountains of papers. The person will never read through the paper. I don't know why we have that, right? So it's, again, the digital environment not used to the way of how it should be used, so that we don't have all this paper, that we don't have to read through this, but that we actually have an environment where we can talk to each other, see each other, and by that help each other and generate something more interesting. These are spaces which are built and where the different city comes together and becomes very dense, and it's not really looking at what people want and how people live. It is about just how you house people. And this is how then the inside can look like in very dense environment, in sort of micro apartments or in places. And it's not about that the people are poor, it's about the spaces which we generate, which is sort of the leftover which the people can use. And that's something where we have actually a responsibility to address these kind of things. And then we provide public spaces, which are, you could say, well, lots of space, but they're similar horrible. People cannot sit, they have to sit somewhere on the side, on the floor. There's fences and so on. So it's not a space where you actually want to be, but you don't have any choice because that's the only one you have. So you can be here or you can be here. It's still not really satisfying any of this. So there is a responsibility which we want to maybe address in our design. Right. Here, this is a movie which you may have seen, how augmented reality can, go to the extreme. So you sit in a bus and everything is augmented to you. So you don't actually need any advertisement. You engage with your social communication, you game, you be informed about lots of things, where the handrail is, how you get out there, what's happening, pure information overflow, and you go out there, and this is how your environment looks like. This is quite interesting if we now think about if we can augment everything, So what do we actually then design? What are the spaces which are then left over that everything is augmented? So you don't actually need streetlights anymore, you don't need any window shops, because everything can be augmented. So what spaces do you have then? And then it goes then further and further, and how you shop and so on. Don't go through everything, but you get the point which I want to make with this image, I believe. Okay, now it shows you something nice at the end, just something beautiful. So we use different 3D printing methods, using, obviously computation to generate the whole thing, and then we produce this kind of things, and it's not trying to mimic nature, but trying to express, something by its own, which could live parallel to a nature, but it's become something, intriguing, because we don't know how it works. It seems to be alive, but it's all printed artificially and putting in this, beautiful presentation. But very quickly we can sort of see certain things of how we interact as human in these creatures, and we have a lot of sensorial stimulation, not only visual, but we want to touch it, we want to feel it. There is something that we generated using digital tools and fabrication, which gives us a very close connection and interaction. Okay. Good. Last slide. Corbusier went to Rome. And I don't want to talk about Corbusier, I want to talk about, he went to Rome. And Rome is obviously a very nice city. And then he made a sketch in the bottom, and then he put these, and basically what he said, well, Rome is actually just all made out of spheres and cylinders. And that's actually quite interesting. He didn't say circles and squares, he talked about three-dimensionality. That's something when we come back to the Sydney Opera House, for example, the complexity. But he also said you can reduce it to very simple forms, but it's about of how you combine these to generate something so elegant or so exciting, so lively that what Rome is. And that's something where we can now think about it. We all develop different designs, but can we design something which is so simple and clear that it allows for something to happen like Rome? Right? Rome was not built by one person, but it allowed, something was there that allowed this to happen, and it is based on very simple ideas and very simple starting points. And if we can manage that, then we win. This is my team. Work not alone, obviously. We have students and we have industry and academic partners, and I'm very grateful to have their support. Thank you very much.